Hello students, welcome back to our class. Now in this module we are going to discuss very important essay type questions from Arithmetic Progressions chapter, and we can expect one question compulsorily from this chapter. Arithmetic Progressions carries 5 marks, so please be focused. What kind of problems may come? See, the very first problem here is the ratio of sum of n terms of two arithmetic progressions is 7n plus 1 is to 4n plus 27. Then find the ratio of their mth terms. So what is the information given here? Ratio of sum of n terms of two arithmetic progressions. Two different arithmetic progressions. So let us start with what are those two arithmetic progressions. So general form of arithmetic progression is a plus d, a plus 2d, a plus 3d, and so on. Now there are two different arithmetic progressions. I would like to consider arithmetic progressions. Let us consider the first arithmetic progression is going to be, first arithmetic progression is, I am going with small letters a plus d, a plus 2d, a plus 3d, and so on. What is nth term? That is a plus n minus 1 into d, and so on. That is first arithmetic progression. And what would be the second arithmetic progression? Second arithmetic progression, I go with capital letters. Okay, because both of them are different, right? A, comma a plus d, comma a plus 2d, and so on, comma a plus n minus 1 into d. See, I did not use capital N here because sum of n terms, number of terms is n only, so that n terms of both arithmetic progressions are given. So according to the given problem, the ratio between sum of n terms of two arithmetic progressions is given as 7n plus 1 is to 4n plus 27. Okay, so first arithmetic progression, let it be small sn. Second arithmetic progression, let it be capital Sn, is equal to, what is the information given here? 7n plus 1 divided by 4n plus 27. 4n plus 27. Now let us try to understand what is the formula for sum to n terms of arithmetic progression, first arithmetic progression. So I would write this as, for the first arithmetic progression, sum to n terms is n by 2 times 2a plus n minus 1 into small d whole divided by, for the second arithmetic progression, n by 2 times 2a plus n minus 1 into capital D, which is equal to 7n plus 1 divided by 4n plus 27. 7n plus 1 by 4n plus 27. See, is there any cancellation? Yes, we can cancel n by 2 and n by 2. What do we want here? Find the ratio between their mth terms. Then ratio between their mth terms means mth term of first arithmetic progression divided by mth term of second arithmetic progression. Mth term is nothing but a plus m minus 1 into d divided by a plus m minus 1 into d is equal to how much? That is what we want. Okay. Now see here, after cancellation, the numerator will be 2a plus n minus 1 into d whole divided by 2a plus n minus 1 into d is equal to 7n plus 1 divided by 4n plus 27. Now you will have to think logically. We need a plus m minus 1 into d in the numerator as well as denominator. But here we have 2a plus n minus 1 into d. So here 2 can be taken common. Of course, in the numerator and denominator, if you take 2 common, then it will become 2 times a plus n minus 1 divided by 2 into d whole divided by, again in the denominator, 2 times a plus n minus 1 divided by 2 into d is equal to 7n plus 1 divided by 4n plus 27. So again 2 and 2 gets cancelled. Now you will have to compare this with this. This is a plus n minus 1 by 2 into d. This is a plus m minus 1 into d. Since you want m minus 1 as the coefficient of d, here the coefficient of d is n minus 1 by 2. So that n minus 1 by 2 should be m minus 1. Did you get my point? If this n minus 1 by 2 is m minus 1, then we will get the mth terms ratio between both the two arithmetic progressions. Did you get my point? So here a plus n minus 1 by 2 into d, and this is a plus m minus 1 into d. So n minus 1 by 2 should be equal to m minus 1. So therefore n minus 1 divided by 2 is equal to m minus 1. So n minus 1 by 2 is equal to m minus 1. Then in order to get the value of n, because we'll have to substitute that n, right? Then it would be n minus 1 is equal to 2 into m is 2m minus 2. Then the value of n is going to be 2m minus 2 plus 1. Therefore, n is equal to 2m minus 2 plus 1 is going to be 2m minus 1. This is what you will have to substitute in the place of n in order to get the ratio between mth terms. So therefore, mth term of the first arithmetic progression by mth term of the second arithmetic progression is going to be, because this is what we want, right? So here in the place of n you write 2m minus 1. So a plus, this is anyway a plus, in the place of n minus 1 by 2 you are directly substituting m minus 1, right? So m minus 1 into d divided by a plus n minus 1 into d is equal to, now here in the place of n you write 2m minus 1. 7n plus 1, that is 7 into n is 2m minus 1 plus 1 divided by 4n plus 27, that is 4 into 2m minus 1 plus 27. So finally what we get here, we get that 7 into 2 is equal to 7 2s are 14m. 7 into minus 1 equal to minus 7 plus 1. Minus 7 plus 1 is equal to minus 6 divided by 4 into 2 is equal to 4 2s are 8m, and then 4 into minus 1 is minus 4 plus 27 is going to be plus 23. So this is what is the ratio between their mth terms. So am divided by am is equal to 14m minus 6 divided by 8m plus 23. This is one of the most important problems. You are given the ratio between some two n terms, then you are asked to find out the ratio between their mth terms. So this is the way of solving the problem in order to find out the ratio between their mth terms. Hope you understand? Right. So moving on to the next problem. Here the next problem is Sn denotes the sum of first n terms of an arithmetic progression. Here Sn would be sum of first n terms of arithmetic progression. What is basically the formula for sum of first n terms? N by 2 into 2a plus n minus 1 times d. This is sum to n terms of first n sum to n terms of an arithmetic progression. Prove that S30. What do you mean by this S30 here? S30 means, according to the problem, sum of first 30 terms of an arithmetic progression. So substitute 30. So 30 divided by 2 times 2a plus 30 minus 1 is 29d. This is S30. And what is S20? S20 is again sum of first 20 terms of arithmetic progression. That is going to be 20 divided by 2 times 2a plus 20 minus 1 is equal to 19d. And similarly S10. S10 is equal to sum of first 10 terms of arithmetic progression. That would be 10 by 2 times 2a plus 10 minus 1 is equal to 9d. So this is about S30, S20 and S10. But what we want here, we need to prove that S30 is equal to 3 times S20 minus S10. Okay, I am going to find the value of S20 minus S10. S20 minus S10 is going to be, what is S20? 20 divided by 2 times 2a plus 19d minus S10 is 10 divided by 2 times 2a plus 9d, right? So here 20 divided by 2, 10 divided by 2, of course both of them are in simplest terms. So we can do one thing, that here 2 1s and 2 10s are 20, and again 2 1s and 2 5s are 10. Finally what we get here, 10 into 2a is equal to 10 2s are 20a plus 10 into 19 is equal to 190d minus 5 into 2 is equal to 10a minus, because minus into plus equal to minus, 5 9s are 45d. So totally 20a minus 10a is equal to 10a, 190d minus 45d is equal to plus 145d. This is what? S20 minus S10. But what we want here, we want 3 times S20 minus S10, which is equal to 3 times S20 minus S10 is equal to 3 times 10a plus 145d. Correct. Can I take one, can I take one 3 common here? Otherwise, we'll simplify and then let us see whether it is equal to S30 or not. Which is equal to 3 10s are 30a plus 3 145s are 3 5s are 15, 5 1, 3 4s are 12 plus 1 equal to 13, 3 1, 3 1s 3 plus 1 equal to 435d. This is what is RHS. Is this RHS equal to LHS or not? Let us check. See here, 2 1s and 2 15s are 30, 15 2s are 30a plus 15 into 29. 15 9s are how much? 135. So 5, 13, and then 15 2s are 30. 30 plus 13 is equal to 43. D. Once you observe here, this is LHS and this is RHS. Are these LHS and RHS both are same? Absolutely same. 30a plus 435d, 30a plus 435d both are same. Therefore, LHS is equal to RHS. See, this problem is nothing new. You can do it easily, but you will have to understand what is SN stands for. SN stands for sum to n terms of arithmetic progression. With that, we can find S30, that is sum of first 30 terms of an arithmetic progression, like the 20 terms as well as 10 terms also. Fine. So moving on to the next problem. Find the sum of first 24 terms of an AP whose nth term is given by, so what is given here? Nth term of arithmetic progression is given. So given that nth term of arithmetic progression, that is an, is equal to 3 plus 2n. An means nth term, a1 means first term, a2 means second term, a3 means third term. So with the help of that a1, a2, a3, we can find out the common difference also, right? So now I will put 1 in the place of n in order to get first term. That is a1 is equal to 3 plus 2 into 1. 3 plus 2 ones are 2 plus 3 is equal to 5. So it means the first term of arithmetic progression is equal to 5. I should find out the common difference. For that, I need second term also. So I will have to substitute 2 in the place of n. Then it would be a2 is equal to 3 plus 2 into 2. So 2 2s are 4. 4 plus 3 is equal to 7. So 7 is my second term. With the help of first and second term, I can find out the common difference. D is equal to a2 minus a1. So a2 is equal to 7 minus a1 is equal to 5. 7 minus 5 is equal to 2 is the common difference. So common difference is equal to 2 and the first term is equal to 5. So with the help of these two, I think I can find out the sum of first 24 terms of an AP. Therefore, sum of first n terms of an AP. Therefore, Sn of AP is equal to n by 2 times 2a plus n minus 1 into d. But how many number of terms sum I required? That is 24 terms. So S24 is equal to 24 divided by 2 times 2a. What is the value of a I got here? A is equal to 5 plus n minus 1. N is equal to 24. So 24 minus 1 into d is going to be 2. Right? So 24 by 2 is equal to 12 times 2 5s are 10 plus 24 minus 1 equal to 23. 23 times 2 is equal to 46. So finally what do I get here? 10 plus 46, 10 plus 46 is equal to 56. So 12 into 56. Now I go with 12 6 are 72, 2, 7, 12 5s are 60, plus 7 672 is the sum of first 24 terms of this arithmetic progression, whose nth term is given as 3 plus 2n. Right? So this way we can find out sum of any number of terms when nth term of arithmetic progression is given. Moving on to the next problem. The houses of a row are numbered consecutively from 1 to 49. Show that there is a value of x such that the sum of the numbers of the houses preceding to the house number x is equal to sum of the numbers of the houses following it. Find the value of x. In fact, this is fourth problem in your optional exercise. All problems in the optional exercise are very, very important, and this problem is comparatively more important than the other problems because you see the past board examination papers, you can see this question quite few times given in board examination. So please be focused on this kind of problems, especially this is purely application based question. Now coming to the problem, the houses of a row are numbered consecutively from 1 to 49. Suppose there are houses like this. This is the first house, okay, and this is second house, and this is third house. Like that, there are some more houses. This is next house, this one is next house, this one is next house, and so on. How many houses are there totally? There are totally 49 number of houses. So this is, for example, 48th house and this is 49th house. These houses are numbered consecutively from 1 to 49. So this house is numbered 1, number 2, number 3, and so on. Last house is 49, and then before house 49, that is 48 number house. Now here, show that there is a value of x such that, means in between there is a house x. We do not know what is that number. That number can be 20 or 30 or 35 or 40 or 45, whatever it is. So there is a number x. Suppose if this is house number x, what is the number before house number x? If it is 20, for example, then what is the house before to that? 20 minus 1, right? So it would be x minus 1, and it would be similarly x plus 1, right? So show that there is a value of x such that the sum of the numbers of the houses preceding to the house number x. Preceding the house number x means before to it. So it means sum of all these number houses is equal to sum of the numbers of the houses following it. Following it means what? After that. So sum of all these numbers is equal to sum of all these numbers. Then find out the value of x. That is what exactly the problem given. If you observe 1 to 49, 1, 2, 3, 4 and so on up to 49, purely an arithmetic progression. But there are two different arithmetic progressions. Okay? So this is one arithmetic progression and this is another arithmetic progression. I will write here what are the terms of arithmetic progression. Here the terms of arithmetic progression are 1, 2, 3 and so on. What is the last number? Last number is x minus 1. So what does this mean? How many number of terms are there in this arithmetic progression? There are x minus 1 number of terms. Because if this number is equal to some 10, 1, 2, 3 and so on up to 10 means how many terms are there? 10 terms are there. Like that, x minus 1 terms are there. Now this arithmetic progression starts with x plus 1. Next term is x plus 2. Next term is x plus 3 and so on. What is the last number? Last number is 49. Is 49 the number of terms of this arithmetic progression? No, 49 is the last term of arithmetic progression. Let us see how many number of terms are there in this. How many number of terms are there in this? In this arithmetic progression, in this particular arithmetic progression, what is A? Means what is the first term? First term is equal to 1. Common difference is equal to 2 minus 1 equal to 1. And you know what is nth term also. So nth term is going to be x minus 1. And how many number of terms are there? That also x minus 1. So the number of terms is also equal to x minus 1. Okay, coming here. In this particular arithmetic progression, please be very careful because it is not direct as the previous arithmetic progression, where the first term is obviously x plus 1 and the common difference is equal to, of course, they are all increased by 1, so the common difference is equal to 1, or else x plus 2 minus of x minus x plus 1 is equal to 1 only. And what is last term? Last term is going to be 49. It was clear. But how many number of terms are there? Number of terms is not 49. See here, from 1 to 49 numbers are there, but we are removing x number of terms because we are starting from x plus 1 to 49. So we are not including till x number of terms. So that the remaining number of terms are 49 minus x only, right? The remaining number of terms is equal to 49 minus x. So number of terms is 49 minus x. Did you get my point? So with the help of this information and this information of both arithmetic progressions, this information according to this, the sum of these terms is equal to sum of these terms. Okay. So I am going to use the small letter small s. Sum of how many number of terms? X minus 1 number of terms, because n is equal to x minus 1. So first I would like to write the formula for sum to n terms of arithmetic progression. Okay. So sum to n terms of arithmetic progression is n by 2 times 2a plus n minus 1 into d. Okay. So after writing the formula, because formula carries marks, sum of these terms is equal to s is equal to, how many terms are there? X minus 1 terms are there. So n by 2 means x minus 1 divided by 2 times 2a. A is equal to 1. In fact, we don't require to use this because we know what is the first term as well as what is the last term. Why don't we use n by 2 into a plus an? I go with that. Because if we use this, again we will have to substitute d also. So that I am going to use that formula. What is that formula here? N by 2 into a plus an. N by 2 into a plus an. So here a is equal to 1 plus an is equal to x minus 1. So minus 1 plus 1 cancel. X minus 1 by 2 into x. So s is equal to x minus 1 by 2 into x means x into x equal to x square minus x divided by 2. This is the sum of terms of this arithmetic progression. Similarly, sum of terms of this arithmetic progression is going to be again n by 2. N is equal to how much? 49 minus x by 2 into a plus an. A is equal to x plus 1 plus an is equal to 49. Observe here, which is equal to 49 minus x by 2 times x plus 1 plus 49 is equal to 49 plus 1 is 50. So 50 plus x divided by 1. So this is sum. But according to the given problem, this sum is equal to this sum, right? So according to the given problem, these two sums are equal. These two are equal. So when you equate both of them, then we get x square minus x divided by 2 is equal to 49 minus x into 50 plus x divided by 2. Okay, so can we cancel this 2 and 2? So after cancelling these 2's, what we get here, x square minus x is equal to, multiply both of them, 49 into 50, I am leaving it like that, 49 into 50, minus 50 into x is equal to 50x, plus x into 49 is equal to 49x, minus x into plus x equal to minus x square. Now see, is there any cancellation? Minus 50 plus 49 is equal to minus x. That minus x and this minus x gets cancelled. And then transpose x square this side, then it would be 2x square is equal to, term left here 49 times 50. Correct? So 2 ones, 2 25s are 50. X square is equal to 49 can be written as 7 square, 25 can be written as 5 square. So x square is equal to 7 square into 5 square is equal to 35 square. X square equal to 35 square, then you can write x is equal to 35. Therefore, the total number of terms are 49. According to the given problem, the required value of x is 35. See how interesting problem this is. So there are multiple concepts involved in this. You will have to use your brain properly in order to find the solution of this problem. So hope you understand how easily we can manage with these 5 marks problems. They are all very, very important, and weightage of this chapter is also more compared to the other chapters, so that please be focused and then you feel comfortable. Hope you understand and enjoy the class. Thank you.